Welcome to the DIY Honda Garage channel. The first step in understanding DTC P0775-7E indicates that the CVT, continuously variable transmission, driven pulley pressure control solenoid valve, is stuck in the on position. This issue arises when the pulley ratio is overdrive while the vehicle is stationary, coupled with belt slippage during driving conditions. The TCM, or Transmission Control Module, identifies this abnormality in operation and subsequently logs DTC P0775-7E. This code can also correlate with DTC P0777, indicating broader solenoid valve issues. The specific role of the CVT-driven pulley pressure control solenoid valve is crucial. It manages the fluid pressure that dictates how the pulley operates. The valve is integrated within the valve body assembly located within the transmission. Therefore, proper diagnosis is essential to avoid potential performance issues that can escalate if left unaddressed. The error associated with DTC P0775-7E centers on the CVT-driven pulley pressure control solenoid valve. This component's primary function is to regulate fluid pressure within the CVT system, influencing the operation of the driven pulley. If this valve is stuck in the on position, it can lead to abnormal performance by causing the pulley ratio to exceed its normal limits when stationary, which is a clear indicator of malfunction. The valve is strategically located within the valve body assembly of the transmission, making it critical to the overall performance of the CVT system. Engaging with the TCM, the solenoid valve's performance is continuously monitored to ensure smooth transitions in gear. If slippage occurs while driving, this affects overall vehicle dynamics, leading to a less efficient power transfer from the engine to the wheels. Understanding the components involved is essential for effective troubleshooting and repairs. Identifying the possible causes of DTC P0775-7E is a key aspect of the troubleshooting process. First and foremost, a stuck solenoid valve may be at the heart of this issue, preventing it from effectively controlling fluid pressure. Alternatively, a faulty transmission control module, TCM, could also trigger this code, as it oversees many of the electronic functions within the transmission system. Additionally, wiring issues contributing to poor connectivity or shorts can lead to intermittent errors, exacerbating the problem. Each of these potential causes must be evaluated systematically to pinpoint the root of the failure. Proper diagnostic procedures and tools are essential for accurate identification and resolution of these issues, ensuring smooth vehicle operation following repairs. The symptoms associated with DTC P0775-7E can significantly impact vehicle performance. One of the most common symptoms is belt slippage, which may manifest as a lack of power when accelerating, leading drivers to experience frustration during operations. Additionally, poor acceleration can also occur when a vehicle struggles to respond effectively to throttle inputs, hindering performance. Drivers may also notice warning lights illuminating on the dashboard, signaling the need for immediate attention. Recognizing these symptoms early on is crucial because they can indicate not just a malfunctioning solenoid, but a broader issue within the CVT system. Observing these signs helps in initiating a quick diagnostic process, preventing further damage, and ensuring the engine and transmission operate efficiently. The initial step in troubleshooting DTC P0775-7E begins with starting the engine to ensure that all systems are operational. After the engine has been started, it is essential to test drive the vehicle in D position, allowing the vehicle to reach a speed of 37 miles per hour or 60 kilometers per hour. This procedure is critical as it mimics normal driving conditions and facilitates the TCM's ability to monitor the performance of the CVT system under load. During the drive, you should pay attention to how the vehicle responds, particularly focusing on any signs of hesitation or unusual behavior, which may indicate the malfunction of the solenoid valve. Maintaining a steady pace is crucial for accurate diagnostics, as fluctuations in speed may lead to erroneous data readings. Capturing this information will later aid in analyses needed to determine if the DTC reappears, confirming the issue, or guiding the next steps in troubleshooting. Following the test drive, the next troubleshooting step involves slowing down and bringing the vehicle to a complete stop. This phase is essential, as it allows for further observation of the vehicle's response and performance. Drivers should be attentive to any irregularities in the vehicle's behavior as it decelerates and stops, as this can provide important diagnostic clues. For example, if the vehicle exhibits excessive jerking, grinding, or instability during this process, it could signal deeper underlying issues within the transmission system. Noting performance changes can offer insights into the extent of the solenoid valve malfunction, forming a critical part of the overall diagnostic picture. Collecting this data becomes particularly useful when cross-referencing with subsequent test results or addressing the issue in future repairs. Once the vehicle has come to a stop, the next troubleshooting step is to accelerate from a stop at full throttle while remaining in the D position. This process involves pushing the accelerator pedal to its maximum to determine if the vehicle can reach the target speed of 37 miles per hour or 60 kilometers per hour. This step is vital for replicating full load scenarios that the TCM monitors for optimal functioning of the CVT-driven pulley pressure control solenoid valve. By observing how smoothly the vehicle transitions from a stop to acceleration, technicians can assess the responsiveness of the transmission system and the condition of the solenoid valve. Any irregularities during this process, such as lagging acceleration or unusual sounds, can give significant feedback on necessary repairs. This full throttle test allows for a comprehensive analysis that aids in confirming whether the initially recorded DTC persists under load. After completing the acceleration test, the final troubleshooting step is to again slow down and bring the vehicle to a stop. This is crucial for monitoring any changes to vehicle performance and whether the DTC P0775-7E resurfaces during this process. As the vehicle slows down, technicians should remain vigilant for any signs of irregularities, similar to the previous steps, as well as the presence of any warning lights on the dashboard. The reappearance of the DTC would indicate an ongoing issue with the solenoid valve or related components. Documenting these results is important, as they assist technicians in evaluating the effectiveness of prior troubleshooting steps and determining subsequent actions required to rectify the identified issues. This observation phase is the culmination of the troubleshooting process, offering valuable data on whether further diagnostics or component replacements are necessary. Once repairs have been completed to address the issues associated with DTC P0775-7E, it is essential to conduct a final repair verification. Start by checking the DTC status to ensure that the code has been cleared and does not reappear upon the vehicle's subsequent tests. Following the DTC verification, a comprehensive performance test should be conducted to validate that the vehicle operates as intended without further signs of belt slippage or poor acceleration. Specifically, testing should include both gradual and full throttle acceleration tests, ensuring that the CVT system engages smoothly and efficiently. Verifying improvements in transmission performance serves as a reliable indicator that the issues have been adequately addressed. Continuous monitoring may also be beneficial in the ensuing days to ensure the issue has been fully resolved. Effective, final verification confirms that repairs are successful and that the vehicle is ready for normal operation. Implementation of preventive maintenance strategies is crucial for ensuring the longevity and reliability of transmission systems, particularly for components like the CVT-driven Pulley pressure control solenoid valve. Regular maintenance steps should include frequent checks of transmission fluid levels and quality. This is vital because low or contaminated fluid can lead to premature wear and failure of vital components within the CVT system, including solenoid valves. Additionally, it is advisable to schedule routine inspections, where trained technicians conduct comprehensive analyses of the transmission system. These inspections allow for the early detection of potential issues before they evolve into significant operational failures. By remaining proactive with maintenance measures, vehicle owners can help prevent related DTC codes from developing and will ensure itself continuous performance optimization. Educating owners on the importance of maintenance is key to achieving this goal. In summary, understanding the role and importance of the CVT-driven Pulley pressure control solenoid valve is essential for diagnosing and addressing DTC P0775-7E effectively. Recognizing how this component affects overall vehicle performance helps in pinpointing issues early in the troubleshooting process. The outlined steps provide a systematic approach to determining both the root cause and appropriate course of action, ensuring that the vehicle is restored to optimal operating condition. From verifying DTC status after repairs to scheduling preventive maintenance, all aspects are crucial for maintaining vehicle integrity. In the end, the objective is to ensure reliable performance and longevity for the Honda CR-V 2023 and onwards. A well-structured approach promotes confidence in addressing transmission issues, enhancing long-term ownership satisfaction. Please like and subscribe to the channel. See you next time.